will contain a bit of theoretical context of the tool, and then it will be a practical experience of using the tool in order to do some reasoning, automated reasoning. I think we were first of all, before I go to the next slide, we have two tools or two websites that I recommend to register. The first one is the website of the tool itself. You just need to go there and register. And the second one is our Slack workspace, which contains the text that we are going to use, so you can copy paste from there, and it's also a place where you can ask questions and participate in a discussion if you have further questions. Okay, so I will be happy if you join it. Also, you don't have to, of course. I think that it was a very interesting talk yesterday by Professor Kowalski, who presented us this logic English. So the underlying idea was that we can take a legal language and we can find a subset of the legal language, or not a legal language, but a subset of English, which is rich enough on the one hand side to capture the legal complexity, the legal language complexity, but on the other hand side, it is also understandable by computers. And once you have a legal document which is understandable by a computer, you can actually reason over that. You can execute programs which tells you conclusions of a certain case applied to the legislation. And this is something similar to what we are going to talk today. So if you remember the talk from yesterday, it would be a great context in order to understand what we try to do here. Okay, so let's start with a simple example. I guess you're a lawyer, so this is not far-fetched, and you live in Scotland. And you get a client who is complaining that he got a fine, and he wants to know if he should appeal the fine or there's nothing to do. What's the legal counsel in this case? Okay, it tells you some cases. I was smoking in a car, and my small daughter was sitting next to me, and suddenly a policeman stopped me and gave me a fine. What did I do wrong? Can I appeal it? Maybe the policeman was wrong, etc. Okay, so we have this scenario, and now the question is, how do we help the lawyer? So we need, of course, to read the legal document. Maybe we are not very familiar with this legal document. This is a smoking regulation from the Scottish Parliament. And we need to understand what the law says, and we need to check if there are further arguments which support or weaken the case. I'm not a lawyer, so this is my understanding of what you do, but if it's not exactly the case, you can just fill in the gap. You also ask the client for further questions in order to establish if the case is punishable or not punishable by law. And you try to find some holes, maybe in the legal argument, if it's a more complicated case. Okay, so I would say that this might be a natural scenario. And now our question, and also I guess the question that, one of the questions that we heard yesterday is, can a computer do that for us, or some of that for us? Okay, instead of sitting, reading the document and trying to figure out what's wrong, what's right, which questions should we ask the client, what happens if the client asks answers specific answers, we can try to use a computer to tell us what to do. Okay, and this is the main goal of the tool that we are going to show today. Before I explain about the tool, I just want to be explicit about two different forms of AI that are very prominent. The majority of methods are based on learning. Okay, learning is when, for example, if you apply it to this case, a learning which just means that you have a tool to which you fed lots of cases, lots of court decisions about smoking in the courtroom. Each one of these court decisions had different parameters. Okay, sometimes you drove fast, sometimes you had a white shirt, many different parameters. And for each one of them, we know the conclusion of the court. Okay, the appeal was rejected or accepted. And then we can try to use an algorithm which, taking into account our facts, will tell us if we should appeal or not appeal. Okay, this is a learning-based approach. In contrary to that, there is the reasoning approach, which is also older than the learning one, and it's used a lot in mathematics, in software verification, in hardware verification. In this approach, the computer makes a decision based on reasoning over the legislation. And in this case, we need to give an interpretation of the legislation to the computer. And here I say interpretation because a legislation itself might be vague and ambiguous on purpose, right? Maybe the lawmakers were not sure what to do there. They are depending on further case decisions, etc. So you cannot really find a formal representation or a logic English representation of the legal text, but you can find one for one interpretation of the text based on the lawyer experience and knowledge. Okay, but we need somehow to give this information to the lawyer, and this in the logic English talk yesterday would just be translating the interpretation of the legal text into logic English. Then we need to give reasoning capabilities to the computer. Yesterday we heard about using Prolog. We are using another approach, but they are relatively similar. And then you can ask computers a legal question. You can ask, what are the obligations? If I violated an obligation, what are my new duties, etc. So this is the reasoning-based approach. This is our approach. I just want to add that learning and reasoning are not strictly exclusive of each other. There are many reasoning tools which are using learning, and we are also planning in integrating learning in the reasoning process, not in making a decision, but in improving the reasoning process. We didn't do it yet, but learning is not something that we are against in this tool, of course. It's a very powerful method. Okay, anyway, I want to discuss some of the advantages of reasoning over learning, and it's also, I don't know how many of you were here in the previous talk here, but it also relates a bit to the previous talk here. First of all, in reasoning, once you are sure that the formalization of the legal text, this interpretation that you put in a language that the computer understands, is correct, then there is no error. The computer produces a proof of correctness, and this proof of correctness can be checked if maybe there are some software errors in the tools, so you can check this by other tools to make sure that there is almost absolutely no error. So this method, once you are sure that you actually use the tool correctly, there can be no error. And this is unlike learning, where there is also always a margin of possible mistake. Also, there is no bias. Reasoning is based on the law, not about learning from core decisions. Okay, so this is a very important distinction, because if you use learning for smoking here, and you suddenly see that all the people who wore a white shirt their appeal was rejected, and those who wore a black shirt, their appeal were accepted. Of course, this is a very artificial example, but just to show the idea here, then the learning algorithm will, of course, adapt it. And the color of the shirt will be one of the factors which affect its decision if you should appeal or not. And so this is a biased approach, right? It's biased according to the color of the shirt. In reasoning, there is nothing like that, because it's based on not on the core decisions on learning, but just from the interpretation of the legal text. Also, and this relates to the explainable AI that we heard before, not all of you were here, most of the reasoning methods generate a mathematical proof of correctness. And this mathematical proof can first of all be used to certify that the tool actually did what it should. The decision is actually based on your understanding of the law and the case. And it can also be used to explain the decisions. Okay, this is a mathematical proof, but it can be translated into a human readable proof. And there are work in these directions, and we heard one of them in the previous talk. Another reason to use reasoning is because learning doesn't deal well with rare cases where there are not so many cases that you can learn from. Okay, it needs a significant amount of documents in order to be able to make a good decision. Reasoning doesn't depend on learning. It can work with the most rare cases in the law and still give you a good answer. And the last one that I will mention here, there might be more advantages, is that it's not affected by language. Reasoning is a symbolic-based approach, and it doesn't depend on any specific language. Unlike learning, which might use, for the learning process, certain words in different languages. Okay, so a white shirt in English is not learned in the same way as a white shirt in German or in French. Okay, so this is completely language agnostic, and you can use it for any language. So once you formalize the law in one language, let's say a European law, you don't need to translate it into other languages. It's the same formalization. So these are the advantages. What are the disadvantages? The biggest one is how to give a legislation to a computer, or interpretation of a legislation to a computer. First of all, can the computer read natural language text? And if not, what can we do? And we heard one approach yesterday, just translate it into logic English. Also, you need to give some reasoning capabilities to the computer. So we have a language that the computer can understand, but is it logical? And if it's logical, is there inherent, and then if it's logical and there is inherent logic behind the language, we can apply some legal reasoning. But if so, how complex is this process? Does it terminate? Does it not terminate? Does it take a long time? If it takes several days in order to get an answer, this is still not very useful for us. And of course, we need to find concrete computer programs which can do the reasoning. So there are some disadvantages, and they're mainly relate to the complexity of the process. Okay, also in mathematical proofs and software verification and hardware verification, so methods will not crash into each other, or train system that will not crash into each other. These tools, similar tools, are used in these domains. There is a lot of work by people in order to be able to formalize these real-life scenarios and prove that they are correct. Okay, so this is a complex process, and this is the main disadvantage of using reasoning. So in this tutorial, we try to make the process easier. This is the aim of this goal, so people can use it. And it gives partial answers to the above questions, and it also will show you how to use the tool that we created. Okay, so this is the introduction to what we do. Okay, so the tutorial is automated deduction with legal texts. The team right now is consisting of me, who is leading this project. I'm doing also some of the programming in the theory. We have another programmer, another person in the theory, and we also have Teresa here, who is a PhD, is a PhD student in law, and she gives us the legal point of view. The first people, me and Alex, are computer scientists, and Matteo is a philosopher. Okay, so we try to combine different skills in this team in order to be able to really address the needs of legal people, legal experts. The tool itself can be found on this website. And by the way, you can stop me at any time in order to ask questions. Okay, I hope that it will be much more interactive. So if you're not sure about anything, or you want to ask a question or point something, just stop me immediately. Okay, any questions so far, or other points?
Do you have a paper describing this work?
We submitted now a paper to Jurix. I should put one in Arxiv also, describing how to use the tool. So exactly what we show here is similar to one of the papers. Yes, and I already told you about the Slack channel. So I'm going now over the three main problems.
Excuse me, could
yes.
you briefly go back, because I cannot get
sure. So maybe I should write down this tiny URL.
I can write it.
You can write it? Okay. So the tiny URL is just a link to join our Slack channel, where you can pose any question and you will see the text that we are going to use, and the URL of the tool is here. So just write the Y5N. This is the tool, okay.
This is the tool. And this like
Y5N. Okay. Thank you. So now I'm going to describe the three main problems that prevent us from using automated reasoning, or try to prevent us from using automated reasoning. And then I will describe our solutions to these problems. Again, they are not perfect solutions, but we try to improve it. We try to make it more intuitive, and I hope to get your feedback about what you think about that. If you see that it's useful, how would you extend it? What are the features that you're interested in? I can also share with you our development website. It's where you can put your requirements, etc. Okay, so the main problem is, again, that we are dealing with natural language. It's a rich language. It has very complex semantics. It might be ambiguous. It might be vague. It might have other features that are not making the life of a computer easier when trying to understand it. So computers can read, of course, natural language. The only question is, can they understand the meaning, precise understanding of the meaning? And there are tools. This is a very active field of research, natural language processing, and there are, of course, lots of tools trying to deal with that. We are not taking this approach, but we are hoping to integrate it again, as I said, and we hope to use some. This is based on machine learning. We're hoping, or some of it is based on machine learning. Not all natural language processing are based on machine learning. We hope to use some of these tools later. Right now, I'm going to show it in a different approach. Okay. And the problem here, we need to give the legislation in a language to understand, and it's not the natural language. Okay, so somehow we need to bridge natural language to computer understandable language. We've seen one approach yesterday, and we are going to show another. The second problem is logic. Logic, first of all, is such a language which we are going to use. Logic English is a logical language, so it's also such a language. Logic is characterized, first of all, it has a restricted syntax. So the expressions, let's say English or logical expressions that you can create are restricted, they are not very rich. And it has clear semantics. And once you have clear semantics, you can understand any sentence in the logical language. You can build tools which try to reason over that much more efficiently. They don't need to guess, they don't have ambiguities, etc. So it's a clear semantics, make it easier for the computer to work with. But now the question is, how do we know? We have to change, we have to translate, right? We started with some legislation in English, and we finished up in a different language. How do we know that our translation is correct? Because if it's not correct, or maybe there are different translations. If it's not correct, then we didn't do anything. The computer understands the legislation differently from what we wanted it to. Okay, so this is the second problem, correctness. And the last one is finding the tools to reason over, right? The more complex the logic is, the harder it is to reason over it. So if the syntax are richer, the semantics are richer, then it's making it harder for the computer to reason over. Not always, of course, there is a big field about that, but this is more or less the general idea. We are going to use deductive automated reasoners. These are programs which understand the syntax and semantics of a particular logic and can tell you if a certain question in this logic is true or false. Okay, this is normally the reply that you get. You can ask, given the facts, according to the legislation or the interpretation of the legislation, given these facts, has the client committed a crime or not? Should I appeal or not? Was the policeman permitted to give me a fine or not? Okay, these are the questions that then you can ask, and these tools will answer. There are other tools that you can use. Once you formalized the legal interpretation, in a language that the computer can understand, you are not restricted only to deductive automated reasoning. You can do counter model finding, and this is what I'm working right now in order to improve in the tool. I will explain when I give the example where it is useful. But counter model finders just try to find a counter model. So if you have a case and the computer told you, I don't know if it's true or false, but I can give you a counter model of why it's true or false. And then you need to improve, ask more questions of the client in order to know what are the facts that you need to assert in order to get a better answer. There are also abductive automated reasoners, which are being able to more or less explain what is missing in order to get a conclusion. And there are other tools which I will not talk about. Right now, we're only focusing on deductive engines. And as I said, counter model finders are next on the list. Okay, so I'm just summarizing. In my opinion, automated reasoning over legal text faces these three problems. We need to translate the legal document into a certain logic. We need to know if the translation is correct. This is a very important step. And we need to call computer programs in order to answer questions about the text. Okay? So this is more or less the idea of automated legal reasoning. Any questions so far about these problems? Do you see other problems that I didn't cover? Okay, if you have later, just stop me. So let's see the solutions. The NAI tool, NAI stands for Normative AI, tries to solve the first problem by using an interface which makes it easier for the user to give some semantic to the legal text. Precise semantic to the legal text, we are using annotations. Okay, so I will show you in a second how it works, but just imagine that you have a legislation, you just annotate the text with more information so the computer can understand it. And this is done by user or legal expert, but as I will explain later, it can also be done automatically. So it's not something that, according to our methodology that I'm going to show next, it can also be done automatically. And you need to do it one per legislation. You can consider it as an effort, okay? This is not an easy thing to take a big legal text, which depends on other documents, and formalize it into logic. The second problem, how to know if a translation is correct. So my background is from software engineering, and in the last 19 years, I was programming a lot. And I found out that one of the best approaches in software engineering in order to create good code, and the simplest process is to use a method called behavior-driven development. In behavior-driven development, I write first what the code should do even before I start coding the code. Okay, I just said if I have, let's say I want to program the plus function, I just said 2 plus 2 should be 4, maybe 5 plus 4 should be 9, and that's it. This is the expected behavior. Maybe I also do it on the 0 case because it's a bit unique, and the negative cases, but that's it. I have 5 cases, and I can now go and proceed and write the function itself. Okay, so I'm going to explain it and show exactly how this process applies to the legal reasoning. Anyway, this is the part that must be done by the legal expert, because this captures the understanding of what the legislation is about. Okay, so if a mathematician needs to be able to tell you if 2 and 2 are 4, a legal expert must be able to tell you that if you take this legislation and you apply a certain case to it, then the result is reject or accept or any other. So this requires a human in the process. And the solution to the last part is just calling provers. Okay, I didn't talk about that it's not that easy to call these theorem provers that I talked about before, because they are complex softwares. Most of them have certain formats. It's not that difficult also, but it's not that intuitive, and we don't expect, of course, users to run them by themselves. So we created buttons. Once you solve the first 2 problems, you can click buttons, and the buttons will call the theorem provers on the back end and will give you answers. And this is, of course, this computation is not done by an expert. It's done purely by the computer. And this is where the tool can save you time and work. If you manage to deal with the first 2 steps, then you can ask arbitrary questions, and you will get immediate answers for that. And you don't need to be a legal expert in order to click a button. Okay, so this is the advantage of the tool. The disadvantage are steps 1 and 2. I also want to mention that this is an academic project. It's free. It's open source under very permissive even license. Because the downside of that, of course, is that both me and Alex, who are programming that, have limited time to spend on that because we have other academic obligations, but we are always working on that, always trying to improve that. One of the things I hope to have is more interest also from programmers who will be happy to join the project and help us work on it. Also, one of the advantages, as I said, is that it's an academic project. It's not supported by a big budget, and it's a prototype. We are adding features one by one. We are adding them according to some kind of a priority list that we have. There are missing things which we really think should be implemented soon. First of all, the logic is not rich enough in order to capture different things that we think it should. It might be easy to edit. It might be not so easy. For example, we don't deal with arithmetic. We don't deal with temporal reasoning, and we don't deal with exceptions in the right way so far. We deal with it in a bit naive way. We also want to improve the methodology by add counter models finding, as I said before. And the user interface has lots of places for improvement. Okay, so it can be used. We used it on legal text already, but this is the hardest part in programming, to create graphical user interfaces. Now, before I go to the live session, which actually shows you the tool and how to use it, I just want to talk about possible applications for this approach, okay? Because I think it's important to understand why should we go to all this effort? What are the benefits of having a computer understanding an interpretation of a legislation? So of course, the first possible application is to help lawyers. Once the legal interpretation was formalized, it's forever stored on the computer. Anybody can use it. Your knowledge as a legal expert is stored on the computer. You can be the only one who uses that, or you can give the access to other people. You can sell the access to other people, etc. Again, there cannot be an error, and I put here a question mark because there might be errors on the translation process. There cannot be error in the reasoning process, or there can be a very small chance of error that we shouldn't care about. This is interesting because in the future you might be able to use these decisions as a valid in court, right? Because the court will admit that a certain theorem prover and the certificate that it generates is a valid document in court, and then you will be able to know the outcome of the court decision when you go there, and there won't be any chance of counter arguments, etc. And again, once you have this certificate, you might be able to explain it in natural language that is understandable by everybody. Other lawyers or members of the office can use this interpretation. As I said, you can give it to others. And it saves you time once you manage to go over the big hurdle of formalizing the text. It saves you time because it can give you instant answers to questions over the legislation for specific cases. So the automation is what saves you time. Possible application 2 is just because we trust the system and because we have certificates and because of the certificates, the lawyer can put their name on the process, or the judge even, or the government can put their support on the process. Then you can use it in order to automate legal processes, some of them. You fill a form online, and a legal answer can be given immediately because some legal expert formalized the legislation behind that. And then you can automate these processes. Okay, so this is not such a futuristic thing because our tool also exposes an API. So if you sit now on your computer and formalize a legislation, you can ask a programmer to interface with the tool and use your knowledge in any other application. Okay, so we have a public API, and this API can be used by any other application in order to take advantage of your work. And then you can create other tools based on that. Another similar application is for administrative processes or informative processes. So for example, if you are in Luxembourg and you want to know if you can apply for a nationality, you can go on the website. It's a very informative website. It tells you, first of all, the law. You can click and read the law. And they also try to break down the different cases of the law. Okay, so somebody sat down, read the law, and tried to make it easier for people to navigate the law. This can be done automatically once you formalize the law. Okay, because the law now is understandable by computer, you can try to find out what are the conclusions at every step, what are the conditions, etc. Okay, so it can really help breaking down the law, understanding the law, creating arbitrary applications. For example, there is an application in India where you have comics pictures trying to help people understand what are the rights and duties. For example, if you bought a computer and the computer doesn't work, if you can go to the shop or not, who is responsible, etc. So they have comics showing you different scenarios. This can be also generated automatically once you have the formalization. Of course, it's more work because you need to generate the comics, but the idea is the same. Okay. So this was more or less the theoretical overview of the tool. Now we are going to show how to actually use the tool. Again, is there any question? Yes?
You talked about the API.
Yes.
Is it already implemented?
So the API is implemented. The one missing thing is the token, authorization token. I still need to work on that. Again, I postponed this part because there are other things and nobody wanted to use it, but I guess it's 1 week work and this will be supported. Okay, so yes, the API exists, just accessing it, the security process in accessing it needs to be improved or created in a sense. Okay, so now we can go to the tool itself. And first of all, we need to create an account. I will create a new account just for the example. is the password. Okay. And let me just put this account here. Okay. Once we go into the tool, you see a dashboard which contains your legislations and your queries. And what we want to do now in this live session is to take this text that I just mentioned, or part of the text. I'm just going to copy paste it. And I'm going to create a new legislation. I'm calling it smoking regulation. And I put the text here. You can see that it already tries to put some style. We are using a text editor, JavaScript text editor. You can cancel the style by clicking the clear here. It removes all style, including annotations. Okay, so now we have a part of the legislation. I just go over it quickly. First of all, Article 1 in the legislation, in the Scottish smoking legislation, explains what is an offense, a smoking offense, and when, what are the conditions, what are the exceptions. And at the end, it says that 3a, a person who commits an offense under subsection 1 is liable on summary conviction to a fine not exceeding, etc. Okay, so this is, I guess, standard. Then you have, we just jumped, we ignored a big part of so there are 19 articles in this legislation. We just took things which are interesting into this demonstration. We jump to the second part where they talk about power to give fixed penalty notices. Okay. And there is an authorized officer of a local authority may, if having reason to believe that a person is committing or has committed an offense under section 1 within the area of the local authority, give that person a fixed penalty notice. And the last article that we are interested in is B6, the second part, 6th article. A person to whom a fixed penalty notice has been given before the expiry of the period for payment of the penalty can give, I think I missed the can here, can give notice requesting a hearing in respect of the offense under section 1. So you can try to appeal. Good. So now that we have that in the tool, we saved it, we might want to ask questions about that. Okay, this is what we are interested in. So I'm going to the queries part. And first of all, choosing the legislation that this query is assigned to, and I just say case 1. Okay, a client came to my office. It's a German keyboard, so it will be a bit harder for me. And complained that he got a fine for smoking in a car with his daughter sitting next. Okay? And he asked, and we ask, we want to give a counsel to this client. Should we appeal? Should we place an appeal or not? Okay, so should we appeal the decision? Yes?
Just because I think it's maybe a matter of fact, should you not add sitting next to him?
Should I not add what?
In your sentence, the first sentence, you were writing that he was smoking in a car with his daughter sitting next to him. Because if you read the sentence...
Yes, of course, of course. There are other things missing here, and one of the processes that I'm going to show is that we need to figure it out, and the methodology will show, but you are right, the language is very important. Sitting next to him, yes, I missed this word. With his daughter sitting next to him, no?
Yeah, to him.
Next to him. Okay. Good. So we have this sentence. We can try, of course, to ask if it's true or false. What you, of course, expect that tool won't be able to give you any answer because the tool doesn't actually have no idea what the legislation is and it cannot even understand what this sentence is, right? It's a natural language sentence. So there is no way the computer, well, there is a way, but this is not the way we want to use in order to understand the sentence. So what can we do? And here comes in the methodology that we developed for using the tool. And again, the support for the methodology is also, so the graphical user interface support for this methodology is also a process that we are working on, but it can already be used. So we decided to use behavior-driven development. Okay, so we have this legislation. And in order to be able to apply it to cases, we first of all need to translate it into something the machine understands, and we need to do it in a correct way. And we decided this is just a methodology, you don't need to use it. You can go now and try to formalize it. You have the tools here, you have all the buttons for formalization, which I will explain next. And you can just go and use it if you have a better methodology, if you trust your instincts, if you understand logic good enough, you don't need to do the methodology. But our aim here is to make logic transparent. We don't want people to deal with the logical language because it's a new language, very similar to computer language, which some people won't want to learn, okay, or they don't need to learn, in our opinion. Okay, so the first step in this methodology is just to pick up all those terms, what we call terms. They might be propositions, they might be terms with variables, with other terms, etc. Just taking them out of the document. So I'm going to do that now and also give good names for them. So the term button is the button here. For example, an offense. An offense is a term, right? It's a proposition. So we just go here and we say Article 1 offense. Okay, we just give it a name that we can understand. It's better to give, the names themselves are completely irrelevant for the computer. As we said, it's symbolic. So you can use English terms, you can use German terms, it doesn't matter for the tool. But when you read it, it's good. Right now we don't, as we said, the graphical user interface is not that sophisticated. We suggest giving good names. Later on, when we improve the graphical user interface, of course, this information can be taken back from the formalization. Okay, so once you give a term to a certain part of the text, this is the annotation I talked about, then the computer can relate this text to a certain proposition or higher order term, of course. We deal also with, for those of you who knows about it, so we deal with universally quantified first order terms, okay, with variables. Okay, so you just go and put all the information with an offense. Of course, it's important that it's an adult. So Article 1 condition adult, and we just copy paste that because this is going to be repeated a lot. Of course, smoking is something that the computer needs to understand. So we put here smoking. It should be in a private motor vehicle. And again, I can put whatever I want here. It's for me to be able to understand. If private motor vehicle is a long sentence for me, and I know that a car for me is a private motor vehicle, I can just call it a car. And this is what I'm going to do. You might not agree that this is the right term, then you can put whatever you want. Again, what we do here is my legal interpretation of the text. Each one of us might have a different one. Now, one of the conditions is that there is a child inside the car. Child. And that the vehicle is in public space. Okay, public space. One thing that is very important is that all these terms must start with a lowercase letter. Okay, as I said, it also supports variables. Variables are uppercase in a similar way to the Prolog language. And if you start a term with the uppercase, it just assumes that it's a variable. So it's important that propositions are used with lower cases. Okay, and then we continue. We also have subsection 1 does not apply to a private motor vehicle that is designed or adapted for use as living accommodation. So let's put it inside also. Designed as a living accommodation. Designed, I will call it home car. And in which at the time the smoking occurs is parked and is being used as living accommodation. Okay, let's put it here. Okay, used home car. Now I go to I will only work now on the first article, and I will let you work on the other articles once we finish this part, if there is still time, and maybe we can help you with this process. A person who commits an offense under subsection 1 is liable on summary conviction to a fine not exceeding level 3 of the standard scale. Okay, so I have a person here again. Now we know my legal interpretation that this person must be an adult, right? It cannot be a child or somebody else. So I already have the condition adult. I can use it from the list here. And the colors are always now the same, so it's easier, make it easier to find it. Committing an offense, we also have it here, and we want to make sure that we capture that. Commit an offense. And under is liable on summary conviction to a fine. Okay, so now we know that there is Article 1 punishment, fine. Okay, so I finished putting all the things that I think are important for making a decision as terms here. And now I can go and use the methodology. So I want to connect these terms. The connectives here having different ways. So for example, if I put that, I have a button here called connective, which gives you different logical terms, but you don't need to consider them as logical English terms for making sentences. Okay, this is very similar to logic English. You just annotate it in order to create a logic English sentence. And you have different things here, obligations, always if, then, etc., which are intuitive. And you can also, you can see, for example, if then means that you need to apply it to two other sentences. And if the first one is correct, then you expect the second one to be correct. Okay? An obligation applied to one, and it just means it ought to be that this something is correct. Permission is similar, etc. Let's skip ideality because it is not relevant to this one. It's more complex. I don't think you will need to use it. You have equivalence, which is very similar to if then. It just means that the two sides are equivalent to each other. Okay, so I can go and I can put it, but who tells me that it's correct? Okay, this is a very important question. So now we try to use this software engineering methodology. First of all, you can go to the vocabulary tab and see all the annotations that you made. Okay, you see all the articles, conditions, offense, punishment, and you can see the text that was used in order to for annotations. Again, I can see many improvements for this part. Also, we are working according to a priority list. So how can we start annotating it in a correct way? The process we suggest is by using a behavior-driven annotation, if you want. So I'm going here and I'm trying to define what is the correct annotation of Article 1. So I'm calling it test 1, okay? And in the test 1, I try to put a scenario and my understanding of what is allowed in this scenario or not. Okay, so a person who drives a car, and you can give a specific scenario, it doesn't need to be general. So for example, if you use variables, here you need to just instantiate them, okay? You don't need to write it for all possible values. Again, like in 2 plus 2, when we defined plus, and we said 2 plus 2 and 4 plus 5 are enough for us to give a description of what the plus is. Of course, it's not true because we need to take 0 and minus into account, but let's assume that this is enough. Then we assume that it's enough also to be able to tell us about 3 plus 3 and 300 plus 300, etc. Okay, so you just need to instantiate it. So a person who drives a car on the main street and is smoking while his little son is sitting in the back. And what else is smoking? First of all, let's say that he's not smoking, okay? We need to give different cases. I will give 4 here. A person who drives a car on the main street while his little son is sitting in the back and he is not smoking should not be liable to a fine. Right? This is my understanding. Okay, so I'm going to write several like that. I need to annotate them. I'm going to do it next. And this explains the behaviors I expect from my formalized interpretation of the text. Okay, so how do I do that? It's a very simple one. And here I can clearly see a much better interface where because all the vocabulary is already known, and I know even which article it is, I can just put checkboxes, and you just check the boxes, or you need to put a value. So we are going to improve this interface also, hopefully soon. But anyway, right now we don't have this support, so you actually need to do the hard work and annotate it. So a person, again, is an adult. He drives a car, so let's assume there is a car involved. Main Street, we assume that this is public space. And I chose Main Street just to show you that you can put any scenario here, and you just need to find out how it fits for the legislation. This is the part of the lawyer. Somebody must understand completely the legislation in order to be able to do that. Public space, little son, so there is certainly a child involved. And he is not smoking. So there is smoking here. And we want to say that this is not the case. So we go to the connective and we choose not. Not something, just the English interpretation. It's the opposite of that sentence. Okay, so we have that. And now we want to ask a question. In our tool, you ask a question by marking something as a goal. You see in the queries, you have a third options here next to the term and connective. And you can specify something that this is the goal of your question. And we have a fine here. And now the question is, how do I capture in a normative language that he is liable or not liable to a fine? Okay, and I may choose that not liable to a fine, and this is my interpretation, is that there is an obligation not to give a fine to this person. Okay, we have a strict language, and we need to find out how to use this language, which has these terms here. Okay, how to use this language in order to capture our understanding of the text. And you will see that I'm doing other things which might be looking weird soon, but this is part of the process. Okay, so here I want to ask, should a person be liable to a fine? I understand it as there is an obligation not to give a fine to this person. So I'm not asking should, you're right. This is not a question, right? We are stating a test. This is a mistake of mine. Okay, let me start it again. The interface is not perfect. The person is not liable to a fine, right? We are not asking here because this is something that we know the answer. Is not liable to a fine. Again, this is going to be the goal. This is what our expectation. And a fine is again here. You have buttons here for redoing and undoing also. So not liable to a fine. This is going to be a negative thing. First of all, you are going to say that it's an obligation. One of the drawbacks right now of the interface is that you have to put, if you create complex sentences, like an obligation, not something, you have to do it top down. I first need to say that this is an obligation, and then I need to say that there is a note. Okay, this is again something that we can fix, but it takes some time on the interface level. Okay, I save it. This is my first test case. Now I can try to run it, but of course it doesn't make any sense because we didn't give any interpretation yet to the legal text. So it might be true or false because of a different reason. This is true, for example, but it doesn't really matter. And you can run a consistency check, which is also very interesting. Consistency checks that a certain formalized sentence is consistent with the legislation. Okay, or the legislation itself is consistent. You might write things like, on red light I'm allowed to drive, and on a red light I'm not allowed to drive. And you formalize both of them, then you get, if you have a red light, then you get inconsistency in your logic, right? Because you can drive and not drive at the same time. So consistency checks, automatic checks, trying to see that because this is an easy one to annotate, but a legal text might be much harder to annotate. So consistency checks try to make sure that you don't have inconsistencies. And we also have another check that called independency check, I will show you later, which is very similar. It tries to see that a certain annotated sentence is independent from the other. Because normally, if it's not, it means that you made some mistake in your annotation. It's just another safety. It's a kind of debugging of the process. Okay, so we have one sentence. Let's write several more. So we go here, we create another we choose again the legislation. Article 1, test 2. Okay, so here he was not smoking, but let's assume that he is smoking. Okay, I will clear it, and I remove the note. And he is smoking. In this case, we need to know a bit more of the legislation. We know that there is the exception, right? It might be a home car. So we need to assert first that the car is not used as a home car. The car is not designed as a home car. Okay, let's take this case. Is not designed as a home car. And in this case, we conclude that the person is liable for a fine. Okay? So in my interpretation of that, it means that the state is permitted to give this person a fine. Okay? You see, I make an interpretation of what it means, liable or not, according to my language. Not liable means that the state is obliged not to give a fine, and liable means, for me, that the state is permitted to give a fine. And why is it interesting and why it is important? Because I'm going to ask these questions later. Okay, it's just because I need to understand my language when I ask questions. So when I want to know if the client comes to my office, what should I tell them? I need to use the same understanding, the same language. So I'm going to use was the state permitted to give a fine, or was the state obliged not to give a fine, in order to console the client if should appeal or not. Okay, so I want to remove this one. First of all, I have another term here. The car is not designed as a home car, so we choose the design here. A very important thing is to save it before going to the annotation part. Because when you save it, this application is a web application. This interface here is running on the browser, but all the operations are happening in the backend on a university on a computer in Luxembourg, University of Luxembourg. So saving is the way to synchronize the two states. Again, there are better ways maybe of doing that. We're going to do that when we have time. Okay, so this is designed as home car, and we just say that it's not. Okay, the person is not liable to a fine. We have to remove it because we just decided this is not true. The person is liable to a fine. And our interpretation is this is a fine. And the person is liable. It just means that the state is permitted to give a fine. Okay, we save it. We try to run it. Yeah, I didn't put a goal. So when you save it and you have any error in the annotation, you will get a message here. So for example, if I now want to put that these two are obligations, okay, let me just finish that because I don't want to do the work again. So this is the goal. I save it. Now, if I do an illegal annotation, I put these two, for example, as a not, right? Not, if you look here, is an English word that is applied to one other sentence, and here I try to put two formalized sentences to that. So if I try to do that and I save it, it will tell me query not saved, an error has occurred. The sentence person was driving a car contains a connective not, which expects one operands but two are given. Okay, so it tries to give you some informative message about that. Okay, I load it again, and this is saved, and then I can try to run it. Okay, again, it tells me that it's correct, but it doesn't matter because we didn't formalize it, the text. So the person is liable to a fine, and we put here permission. So now let's put another case where the person now is not liable to a fine. So I'm just copying the first test here. I'm going again here, creating another query. Article 1, test 3. Okay, in this case, we assume, and again, you can see why you need to write many tests in order to be sure that the formalization is correct. In this case, we said, we are going to say that he was smoking, but it was a home car and it was designed as home car, it was used as home car, and everything is fine, and we are thinking he's not liable. Again, so it's not, it's an obligation not to be liable. Okay, so now we are going to make him smoking again. So now we are going to say that he was smoking, but it was a home car and it was designed as home car, it was used as home car, and everything is fine, and we are thinking he's not liable. Again, so it's not, it's an obligation not to be liable. Okay, so now we are going to make him smoking again. Okay, so now we are going to to save. And we are going to say that the car is designed, again, you can write whatever you want here, designed and used as home car. So designed home car. And used as home car. Okay, now we already get that the test fails. Again, it doesn't mean anything. It just means that we don't have any formalization. I will not do 4, I will do only 3 now. I skipped one of them just to save time. And the point here, you see the query is counter-satisfiable. It means that there is a situation where all these conditions are true and the person is liable to a fine. Okay, this is what it means. But because we didn't formalize the text yet, it doesn't really mean anything, right? This is just a test that we want to make sure that it passes. Okay, so what the process is now, I'm going to create different copies so I can run all the tests. Again, I can see a better, so test 1, test 3, and test 2. I'm opening them next to each other. I can imagine a button that just executes them automatically instead of you having to go to the right pages and click it. And then I open the legislation, and now I need to formalize it such that when I click execute query here, execute query here, and execute query here, I get green messages. Okay, this is very similar to the behavior-driven approach, where you get green light when the code passes all the tests, and you get red light when it's not. So here we get blue one, but except that it's the same process. So let's try to see how to annotate it. Now you apply your understanding, but if you made a mistake, it will be catched by the tests. Okay, so if this is not what I want to annotate. Okay, it is. If it is an offense for an adult to smoke in a private motor vehicle, so we have a very big sentence here just explaining what is an offense and all the conditions. Okay, so I'm going here and I'm saying, okay, these are the conditions, and this is the offense. So it's an equivalence between the offense and all the other. Again, because you have to do it top down, it's a bit confusing. Otherwise, you can just start with the other sentence. We'll solve this problem also. Anyway, you choose equivalence here. And your understanding here is that the offense is equivalent to the conjunction of all the conditions. Okay? So I'm going to put all the other ones as a conjunction. This is an AND. Okay? AND can take as many arguments as you want, and it just means that there is one sentence containing all the conjunction of all these ones. I choose the AND. I save it. Now you always need to run consistency checks to make sure that it's consistent. If it's not consistent, the Turing prover cannot tell you anything meaningful. Okay, it's very important that it's consistent. And now we go to the second sentence. A person who committed an offense under subsection 1 is liable on summary conviction to a fine. So here we also can get different interpretations of what does it mean. My interpretation is that the state is permitted to give a fine to the person if and only if it's an adult and he committed an offense. And it's obliged not to give a fine otherwise. Okay, so we have an operator for that. It's called strong permission. So it's permitted only if these conditions are validated, and it's not permitted, it's obliged not, so it's not permitted to do that if it's not the case. Okay, so again, we choose to annotate it from here with if, then strong permission. Right, if these two conditions, then it's a strong permission to the state to give you a fine. And these are just, again, an AND to conditions. A person who commits an offense is a person, an adult, and an offense. Okay, so we put it here like an AND. We save it. We run again the consistency check. Now I can show you the tab, the formalization tab. I didn't talk about it because this is exactly the relationship between the text and the logic that we don't want people to care about because the interface tries to hide it. But it's still interesting just to see what happens here. When you annotate, we just generate, well, it's not logic English, it's logic. But we can imagine writing here logic English instead. Okay, so it's just the language, the formal language that we choose is a specific one that we define, but we can choose other formal languages. This is just a logic sentence. Okay, just say this is an equivalence sign between the left-hand side and a conjunction on the right-hand side. And here you have a permission P P and this sign is a conditional permission. The state is permitted to do this proposition. Again, this is a symbol. The computer doesn't really understand what it means. We understand in case these two conditions hold. And again, I'm telling you what it is. You don't need to understand it. The whole idea of the tool is to skip this part. I just want to show you what's going on because it really puts it together with the talk we had yesterday. And in addition, because it's a strong permission, in case it's not true that these two are holding, then the state is obliged not to give you a fine. Okay, this is what is being formalized. And now you have the buttons for independency checks. Okay, so when you click that, it tries to see if this sentence, in this case it's very simple, if this sentence is independent of this sentence. Non-independency means that one of them is subsumed on the other. So for example, if you have an article, if you drive illegally, you get 50 euro fine, and the other one tells you that if you drive fast, something similar, you get a 50 euro fine, you might assume that your interpretation might make the drive fast subsumed by the driving illegally, right? It might be the case. So these buttons will find it. And then it means that, yes?
A little confused. The second sentence says liable to fine if offense is committed, right?
Yes.
So how can you derive not liable to fine from a sentence that talks about liable to fine?
Okay, so as I said, my interpretation is that liable to fine is that the state is permitted to give a fine, and not liable to fine is that the state is obliged not to give a fine.
But there's nothing in that
It's here.
sentence to justify your interpretation. In other words, there could be other sentences in the act
Mm-hmm.
to say that the person is also liable to fine for other reasons. So you can
Exactly.
say they're not liable to a fine.
Exactly.
So so you're saying
I'm saying that this is my interpretation for Article 1. If I'm a lawyer and I need to give an interpretation for the whole text, I write tests. So behavior-driven development normally doesn't deal with one function in the code. It deals with the whole code and tries to tell you what's the expected result of running the code as a whole. So it's written by normally the user and not the programmer. And here, yes, I should have said that I apply it to Article 1, but this is not the intended way of using that. You need to write this test on the whole article. For example, here you can ask, he was driving, he was smoking, he had a child. Can he appeal, for example? Let's say that we only have these 3 articles. Can he appeal? And then you take into account all the information in the text. So what Professor Kowalski just said is that here I take an interpretation which is very restrictive, right? I make it strong permission, and there might be other places in the legislation which make it inconsistent, right? In a sense, or will break or won't work with it. If you write the test correctly, you won't be able to do this formalization. This is the point. Did it answer your question?
Well, I think you overinterpreted the English text. The English text does not say.
Yes, strong permission. Now you might ask, why did I do that? Why did I actually use strong permission, not weak permission? It's because I want to be able to answer both true and false in this case. And the tool, the automated tools normally answer only one question. They answer if it's true, not if it's false. Okay, so if I want to be able to tell you if it was permitted to give a fine, I can always do that using the tool. But in order to tell you that the state was not permitted to give a fine, I cannot ask this question because the tool will tell me if something is true, not if something is false. Okay, this is part of this kind of tools that we use. So in order to be able to answer the question, I also need to explain what does it mean not permitted to give a fine. And I did it explicitly here, but again, now I run into a problem that it might not be correct because it's not the right interpretation of the text.
Or the wrong interpretation of not. So maybe your not is really cannot be shown that it is the case. So there's more than one. So you would be justified, in my opinion, if your not meant it cannot be shown rather than it's definitely false, rather than false.
Mm-hmm. Yes.
Which is negation is failure.
Exactly, and we don't have it. Okay, so as I told you before, this is a prototype, and the logic is not expressive enough to capture some things that we think should be captured. One of them is negation as failure, which is one of the things that Prolog supports. Again, we are working in making this interface has nothing to do with the logic. Okay, the logic is just being executed when you click buttons, and we are going to support different logics counter model finders and other tools the moment we can integrate them into the tool. What I'm showing you is a user interface mainly, and how it can be used for your work. Now I have a limitation because I don't have negation as failure. And I want to show you the questions are true or false, so I did not a very good interpretation here. But I could do that because I'm only talking about one article. If I would do it on all articles, then clearly it would be a mistake. Is it clear, this point that I just said? We talked a bit more about the logical limitations here. The point here is that I made an interpretation which some of you won't be comfortable with, and I allowed myself to do that in order to show you a point, and because we are talking only on one article. I wouldn't do a strong permission here if I would just, and it also won't pass the tests if I would do a strong permission here, if there would be some kind of another article in the text which was also allowing you to get a fine or not. Okay, so the behavior-driven development here would prevent you from annotating incorrectly. It doesn't prevent me from doing it now because I'm only talking about one article. If I would talk about the whole text, it might have prevented me from doing that. I think this is the answer I looked for. Okay, so this is something that you don't need to look normally. And the Advanced tab allows you to put these formulas directly if you really want to. We hope that people will only use the methodology and this interface. Okay, so we have some formalization. Let's see if the tests are passing. So we just execute them. And if we see the first one, it doesn't pass. The second one, pass. And the third one doesn't pass. Okay, so it means that our formalization was not correct. Already we managed to make a mistake in this small formalization. I hope it's not too scary that you can make a mistake already on this small example. But if you read what's written here, you can see immediately what's the error. An adult, it's an offense for an adult to smoke in a private motor vehicle when there is a child in the vehicle and the vehicle is in a public space. Subsection 1 does not apply to a private motor vehicle that is designed or adapted for use as a living accommodation, in which at the time, okay, you see the problem here. We took these two as a condition to what is an offense, but it's an exception to what's an offense. Okay, so I did a wrong interpretation. Luckily, I had the test and they found it out. So I have a note here, and this part is actually a negation. And because we have two terms here in the negation, it must get only one. I must put this two in an end. Okay? Now I have a different annotation. Normally what you need to do now, you don't need to sit and try to understand if it's correct. You just go to the tests, and if you wrote the right tests, okay, this pass, this seems not to pass, which is strange. Let me try to see why. Maybe I forgot. Yes, I didn't write that the person is smoking. Which makes sense, right? Because without knowing if the person is smoking, you cannot conclude if he is liable to a fine. So here it says, the backend prover could not resolve the validity of the query. We give a timeout because it's a one server dealing with many things. This normally means, but not always, that the goal does not follow from the assumptions. In this case, you have a counter model. The person was not smoking and he got a fine. Okay, so I'm just putting here smoking. Hopefully now it will work. Okay, so all our tests are passing. Now we have the confidence that our annotation is correct. Okay, without really understanding much about the logical language, just because I follow this methodology and I had enough tests, I can go now and I can say, okay, this is okay. Now I can go and help the client. So let's go back to our case. So we don't care about the tests, we can close them. Now I go back to the case. Remember, we started with this point where we wanted to help the client and we couldn't because the computer didn't understand the legislation. Now we know how to make this text understandable to computer. So a client is an adult and complained that he got a fine. So we have a fine here. For smoking in a car, okay, we have smoking. We have a car. daughter. And now we have a question. Now we want to know if there is an obligation of the state not to give a fine, according to our interpretation, or if the state is permitted to give a fine. If I wouldn't put strong permission here, I would only be able to ask, is the state permitted to give a fine? Okay? And I wouldn't be able to conclude that there is an obligation of the state not to give a fine. Okay, so this means that it's less useful, right? You can answer one question, but not the other. Again, you might be able to capture both sides by writing the right tests and just try to formalize it. One important thing I didn't say here is that once you have the tests, the annotation I just did can be done automatically, right? What's the process involved here is just trying combinations of the different terms and trying to see if the tests are passing or not. Let's assume that there are two different kinds of annotations that will pass the test that I wrote. The tool, if we have the time to implement it, could just give you the two options and ask the lawyer, choose one of these options. So this phase that I just did can be done automatically in the future by the tool. The thing that cannot be done is writing the tests in an extensive list of tests. Okay, so now we're going back to the client. We want to ask, should we appeal the decision? So one of the questions we should ask is the state permitted? And the other question we should ask is the state obliged not to? So let's start with asking if the state is permitted. So here we are asking, okay, I didn't formalize appealing, right? Because this is the third article. So I changed was the state allowed to give a fine? If I would formalize all three articles, I will also be able to answer that one. And this is what I would like you to do. Do we still have time for, or did I take too much time? So I prefer to end now. I hoped that you can also try to do it. Oh, I will just finish this example, okay? So, just writing it. Well, I don't even need to delete it because the text itself is not important. So, should we appeal the decision? I can interpret it as the state permitted to give a fine. I don't talk about appeals because I didn't formalize it. So, I just call it a fine. I can do that. And permitted. You save it, you try to execute. You always need to run the consistency check. So in this case, apparently the state was, well, the tool cannot answer the question. Why? And it will tell you that it cannot answer the question because there are different things that you need to ask the client. So in this case, you go to the vocabulary. It says that it cannot assert it. And you look for conditions the client didn't specify. And you can see here that the client didn't specify if it was public space, I think, and if it was designed or adapted for use as accommodation and other things. So you have to go there. You have to put it explicitly here in this tab. And once you give all this information, you will be able to assert either this answer or the other automatically. Okay? So thank you for listening. And if you have questions now, I will be happy just to quickly to answer a couple of questions. I'm sorry I took so much time. Yeah, I apologize. No questions, you want to eat. Thank you.